Hey, how you doing? Welcome to today's lesson. What we're going to be looking at today is finding the gradient. Okay, probably one of the most important things you're going to be doing with straight line graphs after plotting them. Okay, so finding the gradient. Now, a lot of people have different ways of remembering this. Okay, the thing that I like to tell my kids, and it's not vital that you remember my shortcut, but as long as you remember how to do it, is I like to say it's the rise over the run. Okay, that's not mine. I've seen it in a number of textbooks, and a number of teachers use that as well. All right, but what that is the thought behind this is it's the change in y divided by the change in x. So how far vertical divided by how far horizontal. That's the gradient. Okay, so on my notes there, I now have a very pretty diagram that I've actually been able to take time with and draw it nicely. Okay, it's a little xy axis. Oops, completely missed that. It's just a little xy axis on the notes there. Okay, and it says find the gradient between these 2 points. So it's got this gradient and between 1, 2, and 4, 8. So I'm just going to cheat this. Okay, I'm going to cheat this a bit and not actually measure the things. Okay, if you want to see it measured, it's there on the notes. Alright, so I want to find the gradient between 1, 2, 1, 2, 1, 2, and 4, 8. Yeah, 4, 8. Okay, so what I'm looking at this is I'm looking at two things. The first thing I'm looking at is I'm looking about how far vertical it's gone. Okay, so how far vertical and how far horizontal. So I want this horizontal distance here, alright, okay, so that's my horizontal distance, and then this vertical distance, alright, well, I've got so many things in my hand, ridiculous, I'm like a juggler, this vertical distance here, how far up, alright, now, if you're lucky enough to have squares, if you're lucky enough to be working with the grid, all you can do is you count the squares up, you count the squares across, you do that distance divided by that distance. Done. Okay. But the thing is, I want you to get to the point where you're not counting squares, where you're actually doing this, where you don't actually need a picture. Okay. So let's look at this algebraically. Alright. So, if they say, what is the gradient of this line? Well, the gradient equals the change in y over the change in x. Shorthand for that is delta y over delta x. Okay. It's kind of it's not really 100%. It's not 100% accurate using delta y over delta x, but we understand what it means. Okay, change in y over change in x. Okay, so what I'm going to do is now I'm going to find the change in y. Well, the change in y is that distance there, which is that y, 8, minus that y, 2. So the change in y is on this here is 8, the top one, minus 2, minus the bottom one. Right, so that's the change in y. The change in x, now this is where the only thing you have to be careful about this. If you've chosen that one to be first on top, the y values, it has to be first at the bottom in the x values. So if I've chosen 8 first, then 4 has to go first at the bottom. 4 has to go first at the bottom. Now the change in x, 4 minus the x value, minus 1. Okay, that's important. If his y is first on top, his x has to be first at the bottom. Okay, so now we just do it. 8 minus 2 is 6, 4 minus 1 is 3, 6 divided by 3, the gradient is 2. Easy as that. Done. The gradient of this line, 2. Okay, if you've got the squares, you can count the squares. On my notes, there are actually squares on the picture. So you can count the number of squares. You'll see there's 6 squares there, there's 3 squares across, 6 divided by 3, 2. Okay, now we can just finish this. We're all the way, we can finish it. The last thing we can say is, oh, the c value, y equals mx plus c, is just where it cuts the x-intercept. So we've got y equals mx plus c. Well, m is 2, y equals 2x, plus, well, what is c? It's where it cuts the y-axis. Here, 0, plus nothing. So the equation of this line is y equals 2x. Simple as that. Alrighty. Okay, the important thing is this. Here, can you find the gradient? Right, let's look at one more. Now with a negative gradient. Okay, So again, there's a pretty picture on the notes, all right? But I'm just going to hack together a picture now so that you can see what I'm doing. Okay? So a very quick hack is we've got this, okay? We've got that, XY axis, okay? And we've got the gradient. It's now sloping down from the top left down to the bottom right. So it's actually doing this, okay? This line is doing that, from the top left down to the bottom right. Now when you get really good at this, you'll start to recognize that that's a negative gradient. Okay? But let's just show that it's a negative gradient. It doesn't matter if you don't know this immediately. And it says find the gradient between the points 1, 9, so between the points 1, 9, about there, 1, 9, okay? And the point 3, 1, 3, 1. Let's say 3, 1 is there. Okay? 3, 1, 1, 9. Right. So again, this is what I'm looking at. I'm looking at the change in x, the horizontal distance, dividing into the vertical distance. Okay. So again, the gradient equals change in y over change in x, the rise over the run. Okay. So all that is, well, let's put the blue one first now. Okay. His y value, 9, oh, I said blue one, 9, minus his y value, minus 1, all divided by, now I put the blue one first in the y, so his x value has to go first, 1, 1, minus 3, minus 3. Don't stress about the fact that, oh, I need to make it all positive, so I should actually have a bigger one in front. That's not true. It doesn't have to always be positive. You're not always putting the bigger one in front, okay? You're making sure that if his y is in front on top, his x has to be in the front at the bottom, okay? So now we just tidy this up, and we're pretty much done. Right, 9 minus 1 is 8. 1 minus 3 is negative 2. 8 divided by negative 2 equals negative 4. Okay, so the gradient for this thing is negative 4. If you look on the sheet, right, if you look on the sheet, this intercept, it crosses at 13. So that means now I can write the equation of the line. The equation of the line is y equals minus 4x plus 13. That's it. Done. Okay. Alrighty. Now, let's do one more. Very, very quickly. I'm going to flip back to the other space, because I've got space underneath here to do this last one. Now, here's where you've got to get to, without the picture, because a lot of people are fine when they have the picture, but you've got to be able to do this without the picture, just using the algebra. So, e.g., find the gradient between 1,8 and 3,4 and 3,14. Alright? So, gradient equals change in y over change in x. Change in y divided by change in x. Right? So, it doesn't matter which one you choose first. Let's choose this one first. Okay. Change in y, 8 minus change in x. His y minus his y, 14. Divided by. I've put him first, so I have to put this first. 1 minus 3. Right? Okay, 8 minus 14. 8 minus 14 is negative 6. Negative 6. Divided by 1 minus 3 is negative 2. Negative 6 divided by negative 2 is positive 3. So the gradient that joins these two lines is by positive 3. Okie dokie. Alrighty. That's basically it. Like I said, we're going to get into more properties of gradient, perpendicular gradients, things like that. When you start to talk about coordinate geometry, okay, you start to say about squares, about distances, all that, you start to use this a heck of a lot. You've got to be really comfortable with this, okay? But you have to. If you only take one thing from this lesson, you have to take, if he is in front on top, he has to be in front of the bottom. You have to just learn this. Alright. Okay, there's more on the blog, more on the notes. Remember, I'm here for you.